Hi, it's Mrs. Scarpel, and in the previous video we defined what a function is, and that in order to have a function, each input value has to be paired with exactly one output value. In this video, we're going to take a look at the sets of input values and the sets of output values, and those sets have a specific name. For sets of input values, we call that the domain. So the domain of a function is the set of all possible input values. Now remember, the input values are the x values. The range of a function is the set of all possible output values. And again, the output values are y. So if we look at this function machine down below here, if I input a -2, that's part of my domain, I plug it into my function or my equation, and it spits out, so that's why I get my output, the -6, which would be my y value. So the input values make up the domain, that's the set of values that we plug in for the x, to give us the set of output values, which give us the range of the function. Now we can define the domain and range of a graph by identifying the x and y values used in the graph. If a graph is just a set of points that are plotted, it's not so difficult. We would just say my domain is going to be the x values. I'm going to erase this colon here a minute. I'm just going to use D for domain and R for range. So my domain is going to be the set of the following x values. My lowest x value used in this graph is -3. The next x value is -1, and then +1, and then +3. So that those x values make up my domain. My range values would be the y values that go with those same points. So my y value is 3 on that first point on the left, and then we have a +1, and then we have a -1, and a -3. Now it turns out the values within each set are the same, but if we were to write the ordered pairs, it's not that -3 is paired with -3. Our domain value of -3 is actually paired with the range value +3. So our domain and range can have the same sets of values within them. They aren't necessarily paired together that way. On this next graph, it's not going to be realistic to list every single point that is being used, because we can't list every single decimal point that is used in this graph, because once I start on the left side of my graph, I can trace this graph without ever lifting my pencil. This is an example of something we would call continuous, and we'll talk about that more in a later lesson. So what we have to do here to describe domain and range is use a compound inequality. And we're going to use a compound inequality for both domain and for range. So in chapter 2, we did write compound inequalities that involve x. We just used a number line. We're also going to write a compound inequality for y, so based off of the y-axis. Let's start with domain. So what I'm going to do first is I'm going to mark on my graph where those x values are that I'm using. Oops. There we go. Not drawing so straight today. Thought I had the eraser. Here we go. Erase that little bit of extra. So the domain is within this space. This is my domain. Remember, domain is the set of input or x values. So x is falling between -1 and +3. And because the endpoints of our graph are solid points, our compound inequality is going to have inequalities that are underlined, that are going to be included. And we said that that's between -1 and positive 3. I'm going to do the same thing for my range. I'm going to mark where's the lowest value, where's my highest value, and that's going to represent my range. And I'm also going to write a compound inequality for this range, but because it's range, I'm going to use y as that variable in the center of the inequality. And again, the point at the bottom and the highest point are solid points. So the inequality, that y is included, that point is included, so we need it underlined. And the lowest value of y is at negative 3. And the highest or largest value of y is at positive 2. So we can also write domain and range as an inequality statement, a compound inequality statement. It might even just be a singular inequality statement if it had an arrow showing it was continuing on in one direction. So we can write domain and range as sets of specific values. We can write domain and range as an inequality. So here's your opportunity to write the domain and range for these two graphs. I want you to pause the video and find the domain and range for graph A and graph B. Now let's see how you did. For graph A, the domain is going to have the x values of negative 2, negative 1, 0, 1, and 2. The range will have the values of 4, 2, 0, and then our points use 2 and 4 again, but because we wrote 4 and 2 before, we do not write them a second time. We don't repeat values when we're describing the values used in range or in domain. If values were used more than once, we do not write them multiple times. So because these specific values appeared, we write the values. We don't write how many times they each appeared. For graph B, to find my domain, I'm looking at what x values are being used. And my endpoints are solid, so it's going to be a compound inequality that includes those values from 1 to 5. And then the range, that's the outputs, that's the y values. Also including those points. So again, inequalities that are, or values that are included, so the inequalities are underlined, and we're from 0 to 4. Now, when it comes to input and output, we've got variables that we use because we work off of equations to help us find, well, what's my output when I plug in my input? Or if I know the output, what is the input? So we, excuse me, we have names for those variables. The independent variable is the variable that represents the input values of the function. Well, we've said input values are x values. And what helps me remember this, and what should help you remember this, is independent and input both have the prefix in. So input values go with the independent variable, which is always going to be the x variable. Or if we have an equation that's written similar to y equals mx plus b, it'll be the variable that is where you would normally find x. The dependent variable is the variable that represents the output values of the function, or y. So what is it equaling? Y is going to be your dependent variable. Y is dependent on what we put into x, on what we put into the expression to find y. That's why it's dependent. It's dependent on how this expression simplifies. So if it's not independent, it's dependent. And the independent goes with the input. Again, in and in, prefix in. So let's take a look at this function. C equals 6t plus 8 represents the cost C for T t-shirts plus shipping. Identify the independent and dependent variables. Well, the independent is what's going to help us determine what that final cost is. So the cost is dependent on how many shirts you order. So that means our independent variable is T. And our dependent variable is going to be C. Part B is asking us, or saying, the domain is 1, 2, 3, 4, and 5. What is the range? So I'm going to create a t-table. I'm going to have my domain, or my input values, input is not C, and input is also, I've been using blue, so I'm going to change my coloring. Input is T, because domain is input, range is output. So input, that's T, and range is output. So that's dependent. In this case, that's going to be C. So we've been told that our domain values, or our input values, are 1, 2, 3, 4, and 5. So to find our range, I need to input 1 into 6 times 1 plus 8, which is 14. I need to do the same thing with 2. 6 times 2 plus 8, so 12 plus 8 is 20. 6 times 3 plus 8 is 26. 6 times 4 plus 8 is 32. And then we have 6 times 5 plus 8 is 38. So our range in this case is C, is going to be 14, 20, 26, 32, and 38. So we just substitute or plug in the input or domain values into the expression to find our range values. Let's take another look at a situation. Here we have the function T equals 19m plus 65 represents the temperature T in degrees Fahrenheit of an oven after preheating for m minutes. Identify the independent and dependent variables. Well, m will be that independent variable. And then T will be that dependent variable. A recipe calls for an oven temperature of 350 degrees Fahrenheit. Describe the domain and range of the function. So here's some things we know about temperature and time. We know that we don't have time that's just 1 minute and nothing else. We have time that's 1 minute and 15 seconds, or time is 1 hour, 20 minutes, and 30 seconds. So time is continually moving on. Same with temperature. Temperature isn't just 30 degrees or 36 degrees or 47 degrees. We can have a temperature of 35.8 degrees. So we have this continuous scale. So when we define our domain and range for this situation, we're going to have some inequality situations again. So for my domain and for my range, I'm going to have some inequalities. Now, because my domain is the variable m, when I describe it, I'm going to use m in the middle. And m is minutes, and we know that the least amount of time we're going to have is 0. We're going to have the time before we even turn that oven on is going to be at 0. For our range, we know we're going to use T, and we know the greatest temperature of the oven is going to be 350 degrees Fahrenheit. But we still need to find the maximum for our time in minutes, and we also need to find our minimum for our time, or for our temperature in the oven. Now, if I know that my m value is 0, I should be able to find the temperature of the oven. To do that, so to find this value that goes right here, I'm going to do 19 times 0 and add 65. So 19 times 0 is 0 plus 65 gives me a starting temperature of my oven of 65 degrees. So that probably means the room temperature of my kitchen or within the area of my oven is 65 degrees. So when I first start my oven, I have a temperature of 65 degrees. Now to find how long it takes for that oven to preheat to 350 degrees, I'm going to have to do a little bit of solving. I know that my temperature, I know that my output is going to be 350. So if I look at this function, t equals 19m plus 65, I can substitute the 350 for t, and solve for m, how long it'll take to get there. Now, I don't exactly trust my mental math, so I'm going to use a calculator here when I subtract 65 from each side. And I'll have 285 equals 19m, and then divide both sides by 19, and we have 285 divided by 19 is 15. So it's going to take 15 minutes for that oven to reach a temperature of 350 degrees. So our domain for preheating the oven is from 0 to 15 minutes, and our range of our temperature in that oven is going to be 65 to 350 degrees. So this is some practice, some examples of using domain and range within a function within context.